two subset technologies that make up operating system virtualization: namespace isolation and resource isolation. This application should only get this much of the CPU. And if you constrain it that way, then it can't interfere with another application that also wants the CPU. Application packaging. This is what Docker has brought to the table on top of these fundamental technologies that come with an operating system, is how do you package up an application that's going to be delivered and launched in a container? And then how do you deploy it? And how do you manage a store where people can go get them, or a hub or repository where people can, or developers can go pull images that have been placed up there? Docker has revolutionized containers by bringing in an ecosystem and lifecycle management to containers and application containerization. The benefits that are driving this, besides the reproducibility, besides the fact that the application will always work the same way, it works the same way on the developer's desktop, it works the same way in production, but the operating system virtualization means the application can launch very instantly. And so when you talk about short-lived, scale-up applications, you can scale up instantly, you can scale down instantly, you can dev test very quickly. So developers are driving this. But once you start to package up your application as containers and you start to take advantage of the agility you get, you want to break up those monolithic applications into little microservices, little individually managed groups of applications, like that web tier I showed you earlier. And that's where microservices come into play. You want to describe your application as a collection of discrete subsystems, each one packaged as its own container. And what you get out of this architecture is you loosely couple them so they don't have strong dependencies on each other. When you update one, you don't have to update everything else. You can scale out one without scaling out the others. And you can partition them for ultra scale. So here's a microservice application, 3 microservices. Within it, microservices are built on a concept called a cluster. So you give an orchestrator, a microservice orchestrator, a cluster of resources, and then you deploy the application to it, and it figures out how to place them. And it takes care of the health of those applications, it takes care of scaling out. Every single internet scale company you look at, be it Spotify, be it Yelp, be it Twitter, be it Airbnb, be it Apple Siri, be it Microsoft's own services, are built this way. Next thing you'll see is declarative modeling. So IT has traditionally built up applications and then used scripts and used manual configuration, making the applications completely not reproducible. Every one is its own special pet. And we're moving into a world of what we call cattle. And the way you manage cattle is by defining the way you want your herd to look. And then you can take that template, that model, and deploy it in your dev environment, your production environment, in a different production environment with different requirements. So you bring a definition of the application, you bring some configuration, and you instantiate that in your production environment. You make a change, you can take that change to that template, apply it to your test environment, apply it to your production environment. And the benefit of this as well is that the system itself takes care of orchestrating the standing up of the application, not scripts that are fragile, not humans that can't scale to the kinds of application deployment that we're going to be seeing. So what you're going to see from cloud providers, you're going to see containers as a service. You're already seeing this from the major cloud providers. You're going to see microservice platforms. There's an explosion of them. Each one, they're like programming languages. Each one, people have special likes and dislikes for and meet special business needs. And you're going to see a declarative application lifecycle management. You already see these things with things like Azure's Azure Resource Manager, Azure's Service Fabric, Google Kubernetes, Swarm Compose. All are declarative application lifecycle management systems. So questions for you: which applications should you build on microservices? Maybe take your new ones, maybe decompose your existing monolithic applications. Which PaaS platform meets your needs? There's lots to pick from. And then how are you going to manage and monitor all this? This is the big IT question. I've got lots of microservices, I've got lots of containers. How do I keep track of these things? How do I make sure they're secure? How do I make sure that they're licensed? And then finally, hybrid computing. There's a number of reasons why the public cloud isn't the only thing companies are using today. And they vary. One is network latency. The public cloud, though it's hyperscale, Azure's in 24 regions around the world, isn't everywhere that companies have their customers. And so many cases you need your data, your compute to be close to your customers, and the public cloud doesn't reach. The second is that you might have needs for a private cloud. You might already have a private cloud, and that's not going away anytime soon, even if you do want to move it eventually to the public cloud. And so that's another reason you're going to have hybrid. And then finally, data sovereignty. This one, you've got potentially regulations. You've got cultural norms. You've got business requirements to have the data sit in a certain place. And so you're going to need private cloud if the public cloud's not there. This shows you some stats that show how companies are embracing the idea of hybrid cloud. 3 out of every 4 say that hybrid cloud computing will bring them value. 65% plan on deploying by the end of next year. And despite that, there's going to be a 6x growth in cloud revenue over traditional IT spend because the center of gravity is moving, but hybrid cloud will still exist. So how do companies get onto hybrid cloud? There's a few different ways that we're seeing companies take advantage of hybrid. One is the easy one, backup and DR. Backing up data to that infinite cloud storage, which is cheaper than anything you can get on-prem. Encrypt it so that if you've got any public cloud security concerns, you don't have to worry about them. Dev test infrastructure. Why build out a fixed footprint on-prem when you can use an elastic one in the cloud for your developers as they do their development from 9 to 5? They do the dev test up in the cloud, they bring back the application on-prem. Lift and shift is one where you're migrating applications that are on-prem to the cloud because you're going to save money. Maybe shut those down at the end of the day if nobody's using them. And then cloud-native application development, which is the microservices world for your new applications. Ideally, when you're creating these new applications, you're not just creating them for the cloud, but for on-prem as well. So when it comes to hybrid, you're going to see all different aspects of hybrid. Hybrid storage, hybrid networking, hybrid backup and DR, everything I've just talked about. And one of the things that you're going to also see a focus on is hybrid consistency. So what this is, developers, you want your developers to develop new applications. You want your operators to manage your applications. In an ideal world, the public cloud and your private cloud would look the same. And it would be a seamless set of resources. The decision to put something on-prem to the cloud is a last-minute decision. Or you can even choose to spread your application across the public cloud and private cloud. And the only way to get to that is to have a consistent management and application development environment. And this is a place where you're going to see companies like Microsoft focus on consistent technologies for cloud and on-prem. We've got something called Azure Stack that's coming out. It promises to bring a subset of the Azure cloud services for you to be able to deploy in your own infrastructure. So your operators can manage those application environments the same way that they manage their Azure applications, and the developers can write their microservice-based applications in a way that lets them run in the cloud or on-prem, or they can write their traditional applications so they can dev test them in the cloud and then bring them back easily on-prem. Hybrid networking, of course, as enterprises go to the cloud, they want secure, high bandwidth connections to the cloud. And so you'll see a proliferation of hybrid networking technologies and partnerships between the major cloud vendors and the network service providers around the world. And then finally, you're going to see integration, and you're already seeing this, of on-prem devices and applications and cloud services. Microsoft, of course, we've got a number of on-premises offerings, and virtually every one of them now has some connection to the cloud, whether it's Hyper-V with Azure Site Recovery, the ability to disaster recovery move a Hyper-V application from one data center to another one, or to the public cloud, or Windows Server SQL Server, where you can back up directly to Azure storage. Or more recently with SQL Server 2016, the ability to stretch a table from on-prem to the cloud transparently. So you don't have to worry about whether it's on-prem to the cloud. The hot data stays on-prem, the cooler data moves to the cloud, and you have a scalable table in your databases. So the questions to consider when it comes to hybrid is what data and applications can you move to the cloud today? I'll give you an example that hits close to home. Is Aston Martin has started this journey, a famous company here in the UK. Aston Martin has put their public-facing website on top of Azure. It's one of the easiest things to move, your customer-facing websites. Lots of symmetry, lots of ability to, and application compatibility to move that to the cloud. You're not putting any of your data at risk while you figure out the implications of moving sensitive data to the cloud. But they're also taking advantage of Azure Site Recovery to have a DR plan that can leverage the cloud, and DR between their two data centers using the cloud as the orchestrator. They're also taking advantage of Azure going forward as the place they can burst their workloads into for example, high-performance computing. Another one is, do you want to standardize on something that works on-prem in the cloud, or are you fine having a bifurcated world? An important consideration, because that's going to determine what kind of technology picks you want to make going forward. And finally, how do you motivate your organization to move to the cloud? This is one that Microsoft itself deals with internally. Once you made a commitment to the move to the cloud, you've got to get your businesses to go along for the journey. And of course, the number one way to motivate that is with money, by charging them to stay on-prem versus giving them free access or limited chargeback access to cloud resources is one of the ways that we found doing that. But for every organization, it's going to be different. Every journey to the cloud is going to be different. So that's a quick look at some of the macro trends in cloud computing. We took a look at the explosion of big data and machine learning that goes with it, that is fueled by the cloud, that cloud was basically made for. We take a look at microservices, how you make a scalable application that can deal with that explosion of big data and deal with the agility demands of the modern world that we live in, where every enterprise is taking advantage of on-demand elastic computing. And then finally, hybrid, how we make that transition to taking advantage of those resources. And this is a place where if you're not actively working on thinking about what you're going to do with each of these, I guarantee you that the person next to you, if they're a company that's in your space, is doing it. And so, as with any big technological disruption, there's going to be winners and losers. The winners are going to adapt and thrive. The losers are going to resist and fall behind. And so I hope everybody in this room is going to be a thriver. Thanks very much.
Thanks, Mark. That's great. So our next session starts in 10 minutes. It's going to be a panel session on the future of the cloud. Mark's going to be joining that panel, as well as some people from Google and Nutanix. So if you want to come and stay, for the panel, do come along. It starts at 12:20. Thank you.